Hi Colin, it's Mrs. Francis. I hope that you're having a good day. I am making a little video to show you how to do the calculations for the Mystery of the Flame Lab. So first of all, I want to remind you that we are looking at photons and the properties of photons, which is the energy that is released when an electron goes from a higher energy level and it comes back to a lower energy level. And it does this when it gets excited by some type of electricity or some type of energy. And so there are some properties of each of the waves. So first, I've written down here some things that we know. So these are our knowns. So the first thing is that we know the speed of light. It's 3.0 times 10 to the 8th meters per second. And this never changes. All light travels at this speed. And we put this in the calculator by putting 3.0 and then the EXP button. No multiplication symbol there. Some calculators have an EE button and then an 8 for 3 times 10 to the 8th meters per second.
I need something.
I'll be with you in just a second, Josie. Give me a second. All right, the next thing is that there is an equation to get the 3.0 times 10 to the 8th, which is lambda, which is the wavelength, times frequency. And so that's how often the wave happens. And that will equal 3.0 exp 8 meters per second. So this is the equation in which we get this here. Another equation that we have is that energy equals Planck's constant times frequency. So that is a way for us to calculate energy. And you'll see that both the speed of light and the energy equation have frequency in common. So if you know energy, you could solve for frequency, and then you could put that frequency into the equation for the speed of light and figure out lambda, and vice versa. So we can use these two equations together. Now, Planck's constant is constant, meaning it never changes, and it is 6.626 times 10 to the negative 34 joule seconds. Now, over here, I've taken both of these equations, and I've put them in the triangles in order for you to solve. You can solve via regular algebra, but in this case, it just makes it faster. So if we want to know the frequency, we cover up frequency, and we now know that the equation is c, the speed of light, over lambda, which is the wavelength. We can do the same thing here. If we want to know the energy, we can take Planck's constant and multiply it by frequency. The last thing you need to know for the Mystery of the Flame Lab is that 1 meter is equal to 1 times 10 to the 9th nanometers. Okay, and so you asked about sodium. And sodium has a wavelength of 600 nanometers. And that's because it shines the color orange. So this is how I would do the problem. So number one thing I'm going to do is I'm going to convert nanometers into meters. And I need to do that because all of these up here have meters and not nanometers, so I can't use the 600 nanometers. I've got to convert it. So 600 nanometers times, and then I'm going to put my conversion factor here. And the way that I do this is I say that if there are 600 nanometers here, I will put nanometers down here, and I will put meters up above. Okay, sorry about that pause there. So I'm going to use my conversion factor here, and I see that the number 1 times 10 to the 9th appears before nanometers, so that's where this number is going to go. And then a 1 appears before meters, so this number will go here. This will allow nanometers and nanometers to cancel out and give us the meters unit. To put this into the calculator, I'm going to type in 600 times 1, and I can hit the equals, which should just be 600, divided by 1, and then I need to put this times 10 to the n, and I'm going to just use the EXP button. So I'm going to hit the EXP times 10 to the 9th, and I hit the equals button, and I get a number that's like 0.00000 something 6, and I'm going to hit my FE button, or I can do it manually, and I can find out that this is 6 times 10 to the negative 7 meters. So that's the wavelength in meters for sodium. Okay, the second thing that you've been asked to do is to determine frequency or calculate frequency. So in order to do this, I'm going to take my C times lambda frequency. I'm going to cover up frequency, and now I know that frequency equals C over lambda. I've been given C, which is 3.0 times 10 to the 8th meters per second, and my wavelength is 6 times 10 to the negative 7th meters. Now meters and meters will cancel out, and I'll have something per second, which works well for frequency. So to put this on the calculator, I'm going to type in 3 times 10 to the, which is the EXP button, 8, divided by 6 times 10 to the negative 7th, and then the equals button, and I get 5 times 10 to the 14th per second. This is how many cycles per second there are. That's a lot of cycles, Colin. All right, the last thing that you need to do is to determine energy. And to determine energy, I'm going to use my energy equation, E equals H times frequency. And I'll cover up energy. So E equals Planck's constant times frequency, and that's the frequency that we calculated up here. So it's 6.626 times 10 to the negative 34 joule seconds times 5 times 10 to the 14th per second. Seconds and seconds will cancel out, and now we'll punch this into the calculator. 6.626 times 10 to the negative 34 times 5 times 10 to the 14th. And again, I'm using that EXP button, not the multiplication button when I'm putting the times 10, equals, and I get 3.31 times 10 to the negative 19th, and my only unit left over is joules, and joules is an appropriate measure for energy. Okay, Colin, I hope this helps. I'll take pictures of both of these and send these off to you.